Alright guys, today we're going to talk about compositions and transformations, and this is going to be our last topic that we'll get into. It's going to be really short. We're going to hit a couple highlights here. I'll tell you guys what you can expect to see on your test, the kind of problems, and kind of wrap this up. Alright, so your first definition, a composition of transformations, is a transformation followed by another. Okay, so for example, a glide reflection would be a transformation. It's a composition of transformations. It's a glide, think about a glide, a slide, a translation, followed by a reflection. Okay, that reflection is going to be across a line parallel to the translation vector. I'll show you in a second what a diagram of that looks like. But the main thing you guys need to know is that it's one transformation followed by another. Okay, so let's look at this glide reflection. So basically, I'm sliding first. I have a translation first. This vector is just telling me what direction and how much to go in. And then I'm reflecting across this line of reflection. What this glide reflection tells me is that this line of reflection is parallel to the translation vector, which is telling me which direction to go. So that's an example of what you can expect to see for a composition. One main concept here, guys, is your image, which is going to be your final image, is going to be congruent to your original pre-image. Okay, so here's your pre-image. It translates to your image. This becomes your new pre-image. It reflects to your final image. Well, this is congruent. This is congruent. So by your transitive property, your original is going to be congruent to your final. Okay, so here you go. A composition of two isometries. This is a definition for y'all to know. Remember, it preserves the shape and size of a figure. Okay, so the composition of two isometries is an isometry. It keeps everything congruent, basically. Okay, so this is the kind of problem that you guys will expect to see on your test. And I gave a couple of you guys this in your review because there really weren't a lot in the homework, just so y'all could have some extra practice with this. All right, so triangle RST, we're starting here, and I have it covered up so we can talk through it. Triangle RST are at vertices 1, 2, 1, 4, and negative 3, 4. Okay, we want to rotate it 90 degrees about the origin, then we're going to reflect. So treat these like two little mini problems here. I'm going to take each point, I'm going to reflect at 90 degrees. Remember, guys, you're always going counterclockwise. So I'm going to call my first translation, or excuse me, my first transformation, my primes. I'm going to call my second transformation from there my double primes, just so you guys are familiar with the notation. Okay, so let's take each one. This is a good review on 90 degrees as well. So we'll take it R first. Here I'm at 1, 2. Remember the pattern I told you guys. You're going to flip it. Okay, so I'm going up 1 and over 2 into the second quadrant. So my 1, 2 becomes negative 2, 1. Now my S prime, I'm at 1, 4. He's going to come over here. It's going to become negative 4, 1. And then my T prime is this guy right here. I'm at negative 3, 4. All right, he's coming over here. So that's going to become negative 4, negative 3 into that third quadrant. All right, so this is what our drawing looks like. I'm not going to have you guys draw it, but if it helps you to do so, then by all means take a second to sketch it out, okay, if it really helps you visualize it, which you guys know I always encourage you to do. All right, so from here, guys, what we're going to do is we're going to take this green guy, we're going to take our new image, that's going to become our pre-image, and we're going to reflect it across the y-axis. So we're taking him and we're going to reflect it. Remember, these are going to be equidistant. So your final, this is 2 points away for your R double prime, is going to be 2, 1. All right, 2, 1, this point right here. Our T is 4 points away, or our T prime is 4 points away from our y-axis. So he's going to reflect 4 points away over here. And he's going to become 4, negative 3. And then our S is 4 points away from our y-axis, and he's going to become 4 points away from our axis here, so he's going to become 4, 1. So these are your new points here, guys, of your final image. All right, so again, this is the kind of question you can expect to see on your test. That would be multiple choice. I guess I'll put an extra parentheses here. Let's clean that up a little bit. There we go. All right, a couple things just to get through, guys. The main thing I want y'all to know, this is going to make sense, are these two theorems right here, just knowing those concepts. And then this kind of goes backwards here. Okay, so let's just talk through them briefly. We have one more thing to get through. So the composition of two reflections across two parallel lines is equivalent to a translation. All right, here are my two parallel lines. I'm going to reflect, so I oriented it the other way, and then I'm going to reflect it again. All right, I'm oriented the same way in order to stay on the same orientation and the same distance from my lines here. This is the same thing as a slide, okay? If it was off, up or down, then that'd be more of a reflection. So it stays along the same vector and is sliding at on the same horizon. Okay. So that's basically what it tells you right here. It's perpendicular to the line. So these guys are parallel right here. Your translation vector is perpendicular. It's literally going straight across. It's not going down. It's not sliding down. It's not sliding up. It's going straight across to slide. Okay. The other thing is this is a little different. The length of the translation vector. Okay, so I like to think about 1 point. Let's take 1 point. This point is the same as this point right here. The length of the translation vector, which tells you how to slide, is going to be twice the distance of the distance between the two lines, okay? So I'm going to use the same point right here. Now, if I reflected, this is 1, and this is going to be 1, okay? If I reflected it, it's 1 over, for example, all right? And then from here, guys, let's pretend that I went ahead and I reflected over here. Let's say this distance right here is 5. Well, that means this distance here has to be 5. So what is my total distance that I moved? 1 plus 1 plus 5 plus 5. So my total distance here is 12. Well, what's my total distance between these two lines? 1 plus 5, which is 6. So that's all it's saying is the distance between these two is going to be half of that distance. Don't get too hung up on that, but there's your explanation right here, okay? Your composition of two reflections across two intersecting lines is equivalent to a rotation, all right? So I'm going to reflect, and then I'm going to reflect again. I ended up exactly where I started. This is going to be your center of rotation right here, okay? So the intersection of lines is your center of rotation, the point that it's rotating around. Okay, and that makes sense. I'm going to flip, and then I'm going to flip again. So I ended up flipping over these two lines, which made me orientate exactly where I started. Okay, and then your angle of rotation. This is similar to this concept here, guys. The angle of rotation, this angle here, is twice the measure of the distance here, and it's because they're equidistant from these lines. All right. Going backwards, you guys. So we said that two reflections is equivalent to a translation. Well, also, any translation is equivalent to a composition of two reflections. The composition of two reflections across two intersecting lines is equivalent to a rotation. A rotation can also be equivalent to the composition of two reflections. Okay, and I really think these, if you can visualize these, they fall right into place for you. All right, so we'll just do this as our last example here. Tabitha has created a design for an art project. She reflects a figure, okay, this is our original figure, guys, across line L, and then reflects across line M. All right, so actually, no, we're going to be going across line L here first, and then we're reflecting across line M. So we're going to move it back just a little bit. So this is going to be our M. So we're starting here. She reflects it across line L, alrighty, and then line M. So I like to pick a point. How can we describe a single transformation that moves this from this point to this point right here? Well, at this point, guys, is going to be -1, -5, for example. This point here is going to be 1, 5, all right? You guys can visualize it if you want to, or you can pick a point. That's going to be 180 degrees rotation. I mistakenly was doing M first and then L, okay? But it still gets us that 180 degrees rotation. Okay, guys, this is what I want you to do this before you come into class on Monday, because I have an activity that I want to do in groups on Monday to wrap this up. So this will not take you much time at all. We'll hit some highlights on Monday to make sure y'all are feeling okay with this, see if you have any questions on anything, and then we'll do an activity and start our review for our test on Wednesday.